I wanted to talk tonight about viable service management, and in particular, I'm going to be talking about operational loops. The viable system, I'm going to tell you a little bit about the viable system model and in the operational loops in the context of that, and then I'm going to talk about operational loops in 3 different service environments. First of all, IT service management, which I've worked in. Then in car repair, which I haven't worked in, but I have some experience of having an old car. Oh, sorry. See if I can go, how do we do that? Previous, doesn't look quite the way it used to. And lastly, I'm going to talk about operational loops in healthcare. And then we're going to review the patterns that this shows. So first of all, the viable system model. I hope most of you have some familiarity with the viable system model. I am not going to go through this now. If you're interested, I recommend Patrick's book, The Fractal Organization. And normally when people talk about the viable system model, they talk about what I term the management processes, the ones at the top, the delivery, development, policy, coordination, and monitoring. And also people talk about the structure, the way that the bits of the organization fit inside each other and the same pattern reappears. What I want to talk about today is known as System 1, and it is the operations part of the organization. This is the bit of the organization which actually makes things or does things and produces products or services. And these are sent out, marketed to the environment, or in case of services, they deal with the environment in a slightly different way. Now, going back to the origins of the viable system model, which Stafford Beer explained, I don't know if it was his first explanation of it in The Heart of Enterprise, or whether it was the brain of the firm, but I would advise, if you want to go back there, The Heart of Enterprise is by far the more interesting and sensible book. And I've gone into The Heart of Enterprise and pulled out one of Stafford's wonderful hand-drawn diagrams in which he shows the operations box, in this case, sitting in between 2 different recursive layers, which actually would be above it and within it. Sorry, around it and within it. And I'm going to talk about these 2 loops. These are both feedback loops, and they are both about getting some control on what Stafford calls a muddy box, and which is actually the operations process. And he calls it a muddy box because you can never know what goes on within it, but you do know something about it. So if you think of a production line, we know a lot about a production line, but we don't know everything about it. So it's neither a transparent box or a black box. It's a muddy box. And to control what goes on in that muddy box and make sure it works, you have a number of these feedback processes which ensure that it continues to produce what it's intended to produce. And I'm going to go a little bit more detail into what these look like. So here is Stafford's muddy box. And the first of these loops, which I've redrawn, is got a feedback adjuster in it. And this basically is designed to keep the process operating as intended. So I'm going to get rid of the muddy box now. This doesn't really help us, and call it operation. And I'm going to give you an example of this. So I don't think this is the best example in the world, but it does explain broadly what we're talking about. So first example here of the feedback adjuster in this loop, the stability loop, would be a house thermostat regulating the temperature. It turns on when it gets turns the heating on when it gets too cold, and it turns it off when it gets too hot. And overall, the temperature stays roughly the same, going up and down very slightly. And that's the sort of thing that you get from a stability loop in an operations environment. If then add on to this, the adaptability loop, we have something called that Stafford calls an adjuster organizer. And this alters the feedback adjuster, i.e. the thermostat. And this would be an example of this would be to reset the desired temperature on a house thermostat because maybe you're too cold or you're too hot. So that's a very simple process here. It's an external intervention, And this adapts the thermostat to give you a temperature which is comfortable. And then beyond that, there's another type of loop, which is called a transformation loop. And this can be all sorts of things. It could be something very simple like the thermostat's not working very well, so we're going to replace it. Or it could be, oh, this is crazy. Let's put a new type of central heating system in. We get rid of our oil tank. We'll put a ground source heat pump in. The point about this is that resource is needed, substantial resource in some cases. But I would stress that this could be a smallish or an enormous investment. And this gives us the transformation loop, which transforms the operation. And to use some slightly easier wording, these are the terms I'm going to use throughout this talk. First of all, the stability loop gets it back working. The adaptability loop is about finding the root cause. I'm using the term roots here as underlying cause. It's not a root cause in the sense that you're probably familiar with. So we're going to find the underlying cause, or we're going to do it really differently. And if these loops sit in a manufacturer, they sit inside the organization, which is what this blue box indicates. So the operation is taking place inside an organization. All of the monitoring, which decides something needs to change, sit within the organization. And the only time it goes outside this organizational box is if extra resource is needed and you refer up a level of management. When you move into a service support environment, something slightly different is happening. So these two blocks may be different parts of the same organization, the development manufacture part, and then the service part. But what you can see in the bottom right is the organization box is fuzzy. It fades away. The actual operation that is being serviced is the user using the product or using the service. So this may be you driving a car, this may be you using a computer, but the point is it is not part of the organization when you do that. And a lot of what happens in this area is to do with the organization trying to regain control over these operations that take place outside the normal existence of the organization. The other thing that happens when the operations take part outside the organization is that it is not always the organization that detects something needs fixing. It can be the user. And that gives, again, another dimension to what may be going on. I'm going to start off by talking about the IT service support area, which is an area I worked in for many years. And we wrote this up some years ago in a book, which is probably not brilliantly titled Reframing IT, but the subtitle is Systems Thinking Look at IT Service Management is more appropriate. So what sort of service support are we going to look at? Well, I'm not talking about the sort of service support you get when you phone up a help desk and say, my computer's stopped working, unless you're doing it from an organization. I'm talking about IT service support, which is normally outsourced and happens within large organizations. Some of them are private companies, some of them, or many of them, are large government organizations. I worked in the Department of Work and Pensions outsourcing, I worked in the MOD outsourcing, but I also worked in telecom outsourcing and other private companies. And these companies are some of the companies that provide the outsourcing, and these are all pretty large businesses. So this is where they sit. This is your organization using a blob model from Viable System Model. This is the parent organization and various sub-departments of it. And one of the departments is IT support. And it's normally the whole IT support department is frequently outsourced in these large organizations to these others. And that provides some interesting issues in itself, because the IT support organization actually sort of pretends to report into the organization that's doing the service support to, but actually is reporting to its parent organization. And I'm not going to go into the niceties of that at the moment, but they do provide all sorts of areas of fun and conflict. So here we are in the IT environment. We've seen this before. It's the same diagram, and we've got something that's called IT as a service beginning to emerge from this diagram. And what this is, sorry, I'm going too far now. Start this again. Give me a minute. Okay, so here we have the IT operation going on. I've shown this as a different color because frequently the organization that is doing the IT support is not the same as the organization that did the development, but it can be. And we have this concept here of IT as a service. And IT as a service is something that I think most of you are familiar with now. If you've worked in the Microsoft world, you will probably have stopped installing Microsoft from CDs and more recently download onlines, and you would have bought a contract to use a product called Microsoft 365. Other products are available, and that is IT as a service. Okay, so let's look at a stability loop in IT. What happens in IT in a stability loop? So you've got your software, your hardware running, you're in your large organization, and something is measuring it to make sure that what you're doing works, and it works reliably, and it works quickly. And there's a process running that you are probably not even aware of called event management. And this is about getting it back working when it may hiccup. In fact, it's about probably preventing it from going wrong in the first place. An example of this would be your email in a large organization may go slow and then it speeds up again. And that's because the system has detected that the speed has dropped and will have made more resource available for it to function at the speed that was specified in the agreement. Another sort of stability loop which occurs in this environment is where the user observes something going wrong. And the first thing they would normally do is go and look for some information to help them to fix it. They may, I'm not sure what I've got in here, but I think I've just jumped a slide. But essentially the user is asking for help and is getting help to fix it. So the first thing that the user is doing is looking for information to get it back working. And this is what you do. It's usually if there's something that goes wrong a lot, the help desk will prepare information. They'll put it on a website that you can go and see. And from their point of view, it's almost zero effort. But this is for something which happens a lot. Otherwise, it's not worth them doing it. The next stage is normally where the user talks to a help desk, a triage. And this again is usually of a high volume and the effort is relatively low. The people employed on help desks are relatively low skilled and don't cost the organization a huge amount. If that doesn't fix the problem, then the query will go on to a second tier, tier 2. And these are people with more expertise. There's a lower volume goes here and there's more effort involved. And finally, if something is really hard to fix, it will go to tier 3. And this is a fairly small number of things which will go this far. And quite a lot of effort will be involved in fixing it. And the other thing about this is to note that these different stages, these different tiers, can be provided by different organizations, so that the help desk will be sitting inside one organization. The expert teams may be sitting in other organizations which are more involved with the product. And finally, the third tier will be teams which are often right off-site. I mean, this could be the supplier of the product in the first place. So there is a structure here in how the stability is provided. Now let's have a quick look at the adaptability loop in this context. Here we're trying to find this underlying root cause. And this has a number of possible outputs. Now, the first output of trying to find the underlying cause is that you fix it. Well, that's great. That's what you want. There's also an output which is make a recommendation for somebody else to fix it. Usually this is if a lot of effort's involved. And this recommendation would often go on a list, which is part of the work when they're looking at what resource they've got available. So you're going to get it fixed, but you're not going to get it fixed straight away. There's another way that adaptability loops often operate, and this is a bit of a cheat. It's called you change the standard. So whereas before your problem, which you've identified, your underlying cause, is virtually impossible to fix, supposing it's trying to get emails out within so many milliseconds. This is the standard, it's not being met. They can't fix it. They've decided that the only way to really do it is to change the standard. So instead of having to go out in, I don't know, 10 milliseconds, now they're going to make it 100 milliseconds. And all of a sudden, the problem's fixed. That happens an awful lot. And the last one is the nice one. They call this known error. So instead of it being a problem, it becomes a known error. You could even say it becomes a feature. And no longer do you have to worry about this because it's already known about. So those things all happen quite a lot in adaptability loops. I think it would be naive to think that most underlying root causes are actually fixed. They're not. So in IT support, we have a set of loops which are driven by faults. We have these incident loops, stability loops. We have the problem adaptability loops, and then we have improvement loops. We also have a set of loops which are driven by the supplier. So these are sort of maintenance loops. So they would send out a patch, which you wouldn't necessarily know about, except it says you turn off your computer now, or it'll fix it when you want. You get a refresh, which is usually considerably bigger, although as an end user, you might not be aware that it's a lot bigger. And then you can get a complete renewal. And again, as a user, you might not be aware of it, but you might. This would be something like an update for Windows 10 to Windows 11. I'm afraid I'm not a Macintosh person. And then you get another set of loops, again following this stability, adaptability transformation pattern, where you can put in requests. This is in a corporate environment. You can buy something off the list, or you can buy something that's not on the list, a non-standard request. So that could be something really, really simple. It could be a pink mouse. Or it could be, I want an Apple Macintosh. I don't want one of these nasty Dell PCs. Those are non-standard requests. And there are a huge range of non-standard requests, ranging from something very, very simple, like the pink mouse, right the way up to something almost in the transformation space. Now, in the IT world, the ones I put green lines around are known as ITIL processes. You might remember the title of the book I highlighted was Reframing ITIL. So these are ITIL processes. And it's the ones that aren't highlighted that cause the problems, because people haven't really thought about them enough. And because these support organizations are set up very quickly, they don't have time to evolve, and so these processes don't exist. So if you go and ask for a pink mouse, people will flap around. And the only way they can get you a pink mouse is to set up a project. Now, perhaps they wouldn't do that for a pink mouse, but for certainly other small non-standard requests, they would. And the cost of supplying it way, way, way exceeds the value it delivers. So not having processes for some of these things causes enormous problems. The last thing I want to point out is that these transformation loops at the top, troubleshooting, proactive maintenance, request fulfillment, are actually usually managed in the same way by a single list, by the same decision-making managers. And that's true throughout. So that was IT. So I'm going to look at car repairs. So in car repairs, we have very, very similar loop. We have the processes of manufacturing your cars, and we have the processes of servicing the cars once they are out in the world. And again, we have this division on the right where once it's out in the world, it's no longer part of the organization. And again, the user is frequently involved in identifying problems that need fixing. So let's have a look at some of the stability loops of car repair. So the first thing is what I've called self-repair. Now, not all of these are really faults. An obvious one is the tank's nearly empty, let's fill it up. The headlamp bulb's gone, let's get it fixed. These can be very, very minor. Depending on the skill of the owner and the type of car they've got, the owner can fix the car. And of course, this is something that happens less and less as cars get more and more complicated. So you then have a system where cars auto-detect faults. This is more and more common as more and more computers get into cars. And the car will tell you that there's something wrong, you need to replace this or replace the other. And it tells you to go to the garage. Now, some cars, I'm told, I drive a 25-year-old Volvo, so this is all a mystery to me. But some cars, I'm told, will communicate directly with the manufacturer and will book in your car for a service. It all sounds like magic to me, but there you go. And so that's a great way of it working. Alternatively, of course, the user may find the fault and take it to the garage, and that used to happen a lot more. One thing I've noticed quite a lot is that you have a stability loop, which is a proactive maintenance loop, where you get a little message that says your car is due for a service, or your headlights need looking at, or your anti-skid braking needs looking at, and you've got to go in and you've got to take it. And this is another stability loop, but it's not a fault-based stability loop. It's actually a maintenance loop, but it's also about keeping it working. So again, we have these tiers when we have these stability loops. We have a tier which is look for the information. In the olden days, we had and I can't remember the name of them, but the manuals. Somebody will remember the name that people used to consult to find out how to fix the car. And if that doesn't work, you take the local garage, and if that doesn't work, either you take it to the main dealer, or the local garage will contact the main dealer. And so on and so forth. The more complicated you get, the farther you get back in the stream, the more complexity is involved. And eventually it will go back to the supplier. If you've got an adaptability loop here, where you have a major fault, you again get into a loop, and this time the loop might be replace the car, finding the underlying cause. I have missed making a point that I was going to make, but I'll try and make it in a moment. So these are some of the three sets of loops that you would have with a car repair. You have repair, replace, service, recall, new model, new manufacturer. And the thing I wanted to point out is that the manufacturers are constantly trying to regain control of the operation space, even once the car is out, hence all the automation. And that's one of the motives behind all these computers. So I'm going to move on to healthcare and finish on this. So again, we have this same sort of model of loops in healthcare. Or do we? Well, actually, we don't, because we don't have factories building people. You could argue about maternity services, but I'm not sure it's one that really holds a lot of weight. So when we're looking at healthcare, we're looking at a slightly different system. It does depend where you draw the boundaries. And the process that was called operations, I'm now calling it living. And when you're living, you have things go wrong. And as a user, you want to fix it. You want to fix the symptoms. You want to fix the root causes. You want to do it differently. All the things we've had before, but in a very different context. So if you feel ill, first thing you would normally do is you treat yourself. You'd probably go either to the cupboard and pop a tablet, or you might go to the dispensary and buy buy something, but there are plenty of options for fixing things. If you've got a poor stomach, then you might just change your diet. If you're beginning to feel ill, you might decide that you're going to go and see a GP who will treat you. And again, if it's a simple thing, we'll be able to fix the symptoms by prescribing. You also might have a process whereby most of us do now, where certainly as you get older, where there are regular checkups and screening for all sorts of things. And again, these will end up in you being treated. And you have this same sequence of people that you go to. First of all, you start with information. These days, that's often Dr. Google. And failing that, you then go to the GP. And the GP may refer you for acute to the acute part of the local hospital or the local health service. And if things really don't work out, you may end up going to see specialists in either specialist institutions or in your local hospital. So again, there is this tiering of stability treatment. You also have adaptability loops. You may have the option of changing your lifestyle. This can be recommended by the health service, as in this example. And this is a form of proactive maintenance. You also have all of these adaptability loop issues in health service. If you find an underlying cause, yes, you can fix it. Sometimes. We hope you can fix it. Or you might make a recommendation might be made that a more expensive and complicated intervention is made. You might, it's because I keep clicking on my mouse. You have the option of changing your standard. In this case, it might be your expectations. You had expected to feel well all the time, and you realize that as you get older, that's not going to happen. I'm trying to think of an example of a known error in healthcare. I'm sure there are lots of them, but I can't think of one for the moment. So these are the loops that give us a healthy life. And the transformation loop up here would be a research for new cures. And of course, these are ongoing all the time. So we have a set of loops in healthcare too. And something else is happening in healthcare. When you go across from the illness-driven ones to the maintenance health service-driven ones to what the user wants, we find that the user is trying to take the control loops outside of the organization that's indicated by the blue box. And these are met by lifestyle changes, by dietary changes, and increasing our understanding of our own health. So I just want to reflect a little bit on what I've been talking about here. Particularly IT and healthcare are designed around maintenance of stability. But what people want or need is often transformation. Thought one. Service support loops take place at least partly outside the service organization. The muddy box is muddier. And the ownership of the process is changing in both directions as technology changes and science changes. But we do find recurring patterns across service support in all these areas, and I suspect in almost every other area of service delivery. The organizations which provide the original service are attempting to regain control, to reduce the muddiness of the operation. And there are lots of ways they're doing that. As I say, one of the biggest ways they're doing that is through putting more computers and IT into systems. All the stability loops have what I call self-correction options. This is based on information. And the tiers of support in the stability loops, in all cases I've looked at, different organizations are involved in those different tiers. And finally, there are several outputs options for adaptability loops, and some of those are perhaps not those that people would have expected. And I'd finally like to say thank you, and I just refer you to this wonderful book that I wrote with Patrick and Tony some years back if you're interested in the IT part of this. So thank you very much.
Oh, thank you, Tony. Really, Steve, what am I about? You're mental. I need to sort my own feedback loops out. That was really interesting. It got me thinking a lot about troubles I have with on the rail industry about their operations, and I think it helped me unlock a few things around the loops that exists between the signaler and trying to keep the operations going. So I think that's got me a lot to go away.
I would have loved to have done the railways. I like railways, but I just do not have enough inside knowledge of it to even attempt it.
Ah, right. Maybe.
And I would say if there's anyone in the meeting who finds this interesting enough to want to try and apply it to their own service industry, I'd be delighted to work with you on it.
Yeah, I might have to pick your brains about the rail industry, and do some loops on that. Are there any questions for Steve?
Not a question, but an observation. I'm always recommending Steve's book, by the way. I try, in my 30 years, I've tried to stay away from IT service management because it just, the typical operation sort of, you see the fragmentation between, for example, the people dealing with incidents and people who are there supposedly to deal with problems. And the incidents keep on happening, but they don't get converted into a problem. And then, of course, these days you have remote event monitoring. So basically, a lot of what's going on in the IT, system is all being monitored, and you don't need someone to phone up and tell you that they've got a problem. It's a bit like the car example. The event management people know we've got a problem. And again, the communication between incident management, problem management, and the event management people is typically fragmented. And you even in event management, you have people looking at error logs, then other people looking at other parts of the system, and they're in different teams. And so, as I say, just an observation, Steve, whenever I come across IT service management in operations, and they're doing some design work around it, I say, read this man's book. Because
it's all
about loops. It's all about loops in IT service management, particularly. And it's making sure that within those loops, incident management, problem management, event management, etc., are all connected and part of the loop, and they frequently aren't.
Yeah, I think service management as a whole is probably very susceptible to this, balkanization, which creates all sorts of problems in coordination.
Yeah, absolutely. And the fact that, yes, you outsource it, but you don't outsource just one bit of it to one organization. You might have someone looking after your networks, someone looking after your applications, etc. And they will then, whenever there's a problem, they'll say, no, it's that guy over there. So, again, fragmentation. That's why I stay away.
I've got a question, or a sort of commenty questiony thing. When you were talking about the stability loops, particularly, as well as some of the other loops in there, and maybe you said it and I missed it, but what came to my mind was the concept of homeostasis. Are we in the same sort of space there? Is that the kind of thing we're talking about, really, or not?
Enlarge?
Well, my understanding of homeostasis is when an organism or organization attempts to maintain its present status or condition through movement, despite movement or despite external changes, if you know what I mean. So in the human body, temperature, you try to maintain your temperature within a certain range, no matter what else is going on around you, because otherwise your organs will fry and things like that, So is that a similar kind of mechanism? Is that kind of what we're talking about? Yeah. Just really thinking about it. Yeah, cool. Okay. Thanks.
You get that with capacity management within IT. So the capacity available will be automatically adjusted depending on demand to indeed maintain stability. So yeah.
Steve, if I mean, again, more of an observation than a question, I guess. But I think it's fascinating the parallels between different domains, because I mean, you think what's between the health service, for example, and between healthcare and IT services, you go, well, what's the comparisons? But actually, the mirroring's pretty tight, isn't it? And I mean, a couple of things. One is something which is very, very visible in health, which is the silo. The problem of falling between silos, where you've got different organisations delivering different bits of the thing, which I mean can literally be lethal. If you're trying to access the service. But the other one, which I think we never talk about really, but I mean, I think it really came out quite strongly in what you're saying is, the sort of the trying to get control again from the organization, when actually part of this lives in the lives with the service user, and I mean, you can see that in IT, you can see that really strongly in healthcare, really strongly, because I mean, you get this whole sort of power imbalance between patients and doctors, which is really unstable and unhelpful. And I think, as I say, I don't think we kind of talk about that enough, but it's, what I think what you've just done shows is that that's kind of baked in,
Yeah,
so you've got to really work to counteract that, because it's structural. It's not, it's not an accident.
I think this is almost another layer of detail of the VSM for me, but I can't pretend I've gone into it enough to be sure of that. But certainly, everywhere we've looked, I mean, I originally started thinking this might be more universal than IT service management by talking to my wife, who works in mental health, or worked in mental health social work, and I saw all these parallels. And again, I'm interested in railways, and there's a lot of parallels there too. So without doing more work, I couldn't say this is a universal set, but it's beginning to look as though it may be.
Steve, if you do want to explore the railway connection, obviously you've had some interactions with George Walker, haven't you?
Me?
Yes, or is it Simon who's had Simon? Have you had the interactions with George?
I have.
Well, I mean, George is in railways, so that might be a connection. If you guys can facilitate some, an introduction, that could be because obviously George might be highly interested in this as well from what he does.
Yeah, I can introduce you, but I'd love to. I was thinking about modelling it as well for some of the operations I'm doing, because to be honest, we were looking at structuring operations, but I didn't look at this detail. Like I said, I think this is like the finer detail underneath that definitely worth exploring.
But I mean, this would apply to Network Rail straight on, wouldn't it?
Yeah, stigmas
straight off, which is why I'm thinking of George. The other area that might be interesting, Steve, is whether there's anyone involved in, say, environmental management. That would be probably another prime area to explore with this, because the feedback looks a messy at best, and the muddy box is extremely muddy.
I don't think there are any control loops in environmental management these days, with the cutting of funding of the Environment Agency, for example. It's obviously gone out of the window.
Yes, I made very little of the actual monitoring end of it. I mean, certainly in some situations, how the monitoring is done and who does the monitoring would become very key. Yeah, good thought. Good thought.
And another one, sorry, James just put in a note, but if I could throw it in, Steve, would be actually the education system, particularly tertiary.
Yeah.
So I don't think there's any doubt that you'd find it if you went looking for it in a variety of places. The question I have is, okay, if we assume or even prove that this is in existence, what then? You know, what does that enable us to do? And by that, let me clarify. I mean, it probably is in operation in railways, but phrased like this and used like this, could we do anything about it there, or is that area? Would it not be able to change based on looking at it that way? If that makes sense.
I think there are a lot of questions you can ask. I think the one I found when I was just doing it within IT service management was that the model predicted a set of things happening, and I found it in the non standard requests. And the model said there is a thing called non-standard requests, and I looked, and they were happening, but they weren't planned, so they were wasting money, and they were getting very close to causing the destruction of the whole thing. So I think if you've actually got, and to me, models are there to reveal things that you're not currently aware of, and if you've got one situation where the model becomes evident, apply it to another one where it's less evident, you may see things that were not particularly obvious otherwise.
I think there's another interesting thing, Steve, which is that for me, when I've played around with this before, because I used to do request management processes for BT Global Services when I was in BT, that the interesting point was always what occurs at the boundaries between the two different things. So, you know, sort of the boundary between simple service request and non-standard service request, and then between the non-standard service request and the transformational service request, those boundaries about what fits where and what the processes are capable of dealing with becomes the really interesting part of it, because that's where all the arguments take place operationally. Really fascinating. Jane raised a really interesting point about the measures being the right ones, and about then the feedback being, you know, effectively that what you get as feedback is actually not terribly useful because you end up trying to fix the wrong things.
Yeah, I was. Can you hear me at all?
Yeah.
Yes.
Yeah, sorry. I just see that happening all the time in healthcare because that's my background. And quite often those measures are set by nationally. So there's a lot of talk about user involvement, you know, feedback from people with lived experience, and that does happen. I'm not saying it doesn't happen, but I think it was just picking up on the fact that actually it's the things that we probably don't know and that we're not measuring that actually the important things. So, you know, elected, you know, waiting times, getting waiting lists down. There's all the government's priorities around that, but actually that's important, but there's other stuff that's important as well. And it's people falling through the cracks, people not being referred, you know, all of that preventative stuff, stopping people from actually needing to access healthcare services in the first place. Social care. So it's quite complicated, and I can see the value of, you know, I can immediately see VSM in action, but I think when you're taking a health service, it's actually very fragmented, very diverse, very different. There's no consistency, lots of different contracts. So you'd probably have to kind of hone in on particular areas to actually understand it, you know, make sense of it in more sense. And the other thing that you are quite interested in Vanguard, because some of what you're talking about was kind of the old kind of failure demand, isn't it? It's understanding the customer journey or the patient journey or whatever we want to call it. Where are things falling down? You know, what is that? Where are the processes not working for people? Where's the system not working for people? So yeah, my brain is just working overtime.
That's really interesting, because I remember having huge arguments in BT because they kept on saying, oh, well, you know, incident management is a way of serving a customer. And I went, yes, but all incident management in IT service management is therefore failure and unwanted demand. You don't actually want any incidents. Never mind, you know, let's do incidents really well. Let's not have any incidents would be the other way of approaching it. So that falls back into your, you know, failure demand point as well. And actually people kind of got obsessed with, well, let's do, you know, this is about the kind of Rasakov stuff about doing something that you don't want to do really well. Whereas we're going, let's just not have incidents. Then you wouldn't get rid of the damn things, and then that doesn't matter whether you do them well or not because you don't have any.
And a lot of contracts are built around that false premise that what you want to do is do incidents efficiently rather than you want problems to get rid of them. But just taking on Jane's thought about the complexity, I mean, one of the things that I realise when you're talking about that is this may provide a simple model which could be used as a coat hanger for visualising a whole bunch of what are really quite complex situations and showing how they fit and where they fit together, which is how my simple mind sees models.
I think as well, Steve, on the, you know, one of the big debates in healthcare is about, you know, preventative rather than reactive. You know, that comes up again and again. You know, you think diabetes, and, you know, comes up again and again and again. And in a sense, you've got something that's not the same, but it's analogous in IT. So, you know, people buy these outsourced services really so they don't have to deal with the complexity of the IT estate. And what they actually want is transformation. But the services aren't designed for transformation. They're designed for steady state. They're designed as homeostats. You know, so you're actually buying something that's the antithesis of what you want.
Yeah.
You know, there's so many interesting things in it, I think. But from a health point of view, you could kind of look at those different loops as you went from left to right and go, where should we be putting our money? You know?
Yeah. But it's really interesting to go back to Jane's point again. Who is it who makes the decisions about what measures are then applied? It's typically people who really don't understand it systemically at all.
No.
I don't think generally there is anyone in charge of this sort of system.
It's interesting, isn't it?
I mean, there are some things that happen, you know, these strong moves to internalize and control. But I wouldn't go so far as to say there's somebody actually managing that at any point. Because not all of those loops are within the control of any one manager, especially in service management. Yeah,
the nearest I ever saw it was in telecom, Steve, when they had the TR9000 standard, and the whole idea was that you had interlock metrics that operated all the way up and down the supply chain from the service provider all the way down to equipment manufacturers, and they could make a link between like, you know, Cisco routers and whether a customer got a good IVPN service or something like that. So, but it is hard to do, and it requires an awful lot of dialogue and discussion about what are the metrics and how do they work.
Simon, you get your hand up.
Yeah, I think another complication with the healthcare context, particularly when you're looking at moving to prevention and all of that stuff, is the company owns the IT, let's say, right? I, as a user, am frustrated that it's not working. I, as a driver, might be frustrated that there's something wrong with my car. But the car and the computer aren't sapient things. Well, at least not yet, right? Whereas with the health system, we're dealing with people who have opinions and values of their own. You know what I mean? So you're looking at it as a system and saying, how do we control it? And how do we fix it? And how do we do things to it? But the thing that you're looking at has its own views as well. So, you know, this concept of who sets the criteria and what are the conditions and by what process do they do it has to involve the people that are actually, you know, the object of the system as well. And that makes it much hairier than dealing with the other issues, I would suggest.
Yeah.
Does that make sense?
But with the complication, Simon, that's often not how it's done.
Yep. We forget that
you've got
as objects, and
you've got the whole principle of you know, informed consent, which is supposed to ensure some of that and patient choice and stuff like that. But a lot of the time it just does not work. You know,
and I think we see, and I think that's exactly the point. We see that, right? I mean, a computer can go through a process and get fixed, or your IT, your software can have downloads and change settings, and all sorts of things can happen. But people who have their own views, values, and opinions going through this process can't be treated the same way, and yet we do treat them that way.
Good point.